So yeah, I'm going to talk about building an open source remote pair programming app. And yeah, a really short agenda, who am I, and then I'm going to talk about what's pair programming, what are the benefits of pair programming, and a little bit the reason why attention economy is killing us, and I will link this to pair programming. What is HOP, the open source software we're building, and the technical challenges to make pair programming work. So yeah, a little bit about me. I'm Costa Alexoglou. I am originally from Greece. The last 5 years I live in Malmö, Sweden, and I work at Grafana Labs as an engineer, and at the same time I'm the maintainer of HOP. So yeah, from you, who knows what pair programming is? Okay, almost full house, amazing. So yeah, I will just again give the definition of what pair programming is. If it's in person, we have one monitor, maybe two keyboards, one screen, one OS, one editor, and two or more people writing code together. And if it's remote, we can have multiple participants. One of them is sharing their screen, their editor, multiple who can write there. Yeah, and beyond the definition, anytime developers collaborate or they design architecture, they brainstorm ideas, they debug together, it's pair programming. Yeah, and the benefits around pair programming, and I rediscovered this around 3 years ago, working remotely from a friend, not from a friend, from a colleague from Germany, so we need to collaborate a lot together. I really liked those three benefits. First of all, instant code reviews. So imagine you go to GitHub, you go to GitLab, you make a merge request, a pull request, and as soon as you land this, effectively the other person have already reviewed the PR for you because you've built this together. So you accelerate the review. Of course, you end up with better architecture because you align on this beforehand, which is really nice. So you don't spend 3 days building a PR, building a merge request, and then a colleague of yours coming and saying, this is crap, refactor this, and you end up spending 3 days. And the last one that speaks close to my heart, and I will elaborate more, is better focus on productivity. Yeah, and if you want to learn more benefits, highly recommended the talk from Farhan. I can pronounce his surname. He's a VP of engineering at Shopify, really huge advocate of pair programming, and he encourages every engineer on his team to pair program. Yeah, for the last benefit, I want to talk a little bit, just a few minutes around why attention economy is killing us. Well, that's a catchy title, but then how pair programming helps us as developers. So we have social media, Snapchat, Instagram, X, TikTok, whatever, many social media. They track us across the web with analytics. They try to get our attention for ads, of course. Then we have the search engines. They do exactly the same thing. We have Google Analytics. We have Bing tracking us, try to sell us ads. And then, of course, we have video streaming apps, Netflix, YouTube, and the list goes on. Lately, it's even more weird. We may end up even having ads in our programming framework, so you can see an ad from LogRocket if you're an old developer, which is bizarre. If anybody have used AMP, it's a coding agent, they experimented by serving ads to the free model. So you can imagine ads literally everywhere, even in our code editor. Yeah, as the time passes by, I think the economy, in quotes, is winning our attention because you can see a sharp decrease from 2004 to 2022. So we went from 150 seconds to 44 seconds. This is a chart from a book from Gloria Mark called Attention Span. So you can see literally our attention span is decreasing. And I can feel this personally. I mean, 20 years before versus now, my attention is way lower. And on top of that, how many of you are using code agents at work or in personal life? Not all of you, okay. But on top of that, if you use AI, we have the productivity promise that you're going to be 10 times more productive. So if you heard the news about OpenClaw, which was super popular, the man on the left, he was writing with 20 agents running at the same time. Suddenly his GitHub was super green, being super productive. The other one in the middle, 12 terminals, all of them AI agents running something. So you get the idea that you're super productive. And what we think is happening is that we have an agent. What we think is happening is that we have an agent, and then we review at the same time to PR, we go to agent 2, we reply to an email, we do a proof of concept for $1 billion idea we just had with another agent, agent 3. So we think everything is running in parallel. But the reality from my perspective is, and now with AI, we start an agent. So as soon as it starts thinking and writing code for you, you go back to scroll Reddit, scroll Twitter, reply to emails, then you go back to the agent to fix probably the slot that it produced, reprompt this, and get back to work. So it's definitely a different reality than the one we think that's happening. And I think this reflects it nice. So the XKCD comic, back in the days it was saying, code is compiling, so developers were not working. Right now they say LLM is running. And the GIF, I think, is literally representative of nowadays. So you let the agent do the work for you, and then you go and scroll, TikTok, Instagram, whatever you please. So that was the third point that I think pair programming solves, which is, what else? Okay, the 3 should be there. But effectively, when we pair program with our teammates, we have a goal in mind. So we call our teammate, we hop on a call, and then we try to solve something. That can be a new feature request, that can be a bug that we're solving on an incident we need to tackle. And at the same time, I really like something that's called the Hawthorne effect, which states that you behave differently when somebody's looking at you. And I think it happens in pair programming. So when I share my screen, or when I need to control my teammate's screen, I will not, scroll the emails or go to Reddit, read news, go to LinkedIn and everything. I will be super mindful on the task I have to accomplish. So from my perspective, when I started pairing, that was literally the medicine in quotes around the fragmented attention I had, and really increased my productivity. So yeah, can I see some hands on who collaborates with their teammates with screen sharing? Okay, a few people. So that's a form of pair programming. So the very first thing when you share your screen and you remote collaborate with your teammates is that the first thing that you will ask, can you zoom your screen? That's literally the very first thing you ask. So if you have an ID, you end up with an ID looking like this because you need to zoom a lot just so you can see the character. So if you pair with Google Meet, Slack Huddle, Microsoft Teams, you don't have high definition streaming there. So you will need to zoom in, which is bizarre because this is not the native developer environment we're used to program. Yeah, so based on that, 2 years ago, I was trying to find an alternative, so I was pairing a lot with the guy from Germany. We paired with Google Meet and Slack Huddle. And yeah, I was so frustrated because the image was not high definition of the other screen. I could not remote control, so I was always instructing him, go here, go there. We were debugging Grafana dashboards, and I needed to instruct how to zoom into a region to understand what is happening, where to hover. Another thing, if you have paired with inside the editor, like with Code with Me or live sharing VS Code, you need to share links, which is also not the best experience. And the last point, we're in the foss-north. There was no OS as alternative for really good pair programming calls. Yeah, and those were the alternatives I tested. So it was Screen Hero that later became Pop. So Screen Hero was acquired by Slack, and then the founder vested his shares, and then he started again exactly the same product, but it's fairly unmaintained right now. And also you didn't have one-click call, so you needed to share a link. Then it was Drovio, a French one. It's $15 per user per month, but super ugly and super buggy, so it wasn't like fitting the criteria. And then there was Tuple, an American one, amazing experience, but they charge $30 per user per month, which is super high. I mean, if you're a European company and you say to your engineering manager, I want $30 per month per user on my team to expense, I mean, probably they will laugh at you, they will not expense it. They will just say, use Microsoft Teams or whatever you use. And on top of that, nothing was open source. So yeah, I thought to myself, it shouldn't be probably hard to build, which it was a mistake after around a year and a half of building this. But it was a nice opportunity to learn how we can do this. And then, of course, it's open source, give it back to the community, and involve this. It's not like a state secret. It should be now open source. So when we started building this, we had some goals. One was to be performant, and I will elaborate more on what does it mean to be performant in pair programming, open source, of course, and cross-platform. Right now we support Mac OS and Windows, and we are looking to support right now Linux. So also if you want to contribute, it's okay. So what is Hop? Hop is a pair programming application that is super low latency, less than 100 milliseconds round trips. And I will break this down, what do we mean by this. It allows for remote control, it allows for drawing, and one-click calls. So how does it look like? We have the editor, we have the screensaver, basically screen. So this is how the screen of our teammates will look like. Here we have the main window, and here we have the camera window. And we can even go, I'm not sure how is it gonna work. I'm in the conference Wi-Fi, so it's a disclaimer. So let me, this is how you call a teammate. So I'm calling my teammate. This is the one I'm building Hop with. This is actual Hop. And can you ask me, do you hear me? Yeah, amazing. Can you share maybe the screen so we can show a demo of how Hop looks like? So this is the camera sharing. This is an actual call. Let me close the camera. And this is the demo. So one of the functionality, so you can see by default we share with 4K resolution. So one of the features we have is drawing, so you may not feel super comfortable controlling your teammate's screen, or you just want to point out. So you can draw, shapes, you can click around, and of course the remote control. So as soon as I perform an action, it's immediately reflected here. So it should be super, super clear, even in small text. And again, we share by default with 4K, and this is one of the benefits, one of the differences between pairing with Slack Huddles or Google Meet. Jason, thank you for the help. I'm closing it. Nice. Okay, demo worked. So yeah, the app architecture. So how we build the app. When we started the project, because it was going to be open source, we wanted every single component to be able to, for the contributors to run locally on your laptop without you having to go and create an API key somewhere using any cloud service. So for that, all the components are handpicked. First of all, we used Tauri. Tauri is an app builder based in Rust for cross-platform application development, which was pain in the ass. At the end of the day, I will elaborate more on why. Then LiveKit. LiveKit is a WebRTC infrastructure, which is also open source. So they have a cloud offering, but you can run this locally. So if you ever use ChatGPT, the voice agent, they use LiveKit, so it's really, really nice, cool tech. We use Winit. Winit is window management in Rust. WGBU, GPU rendering in Rust, and ice.rs, it's a UI framework to build quote-unquote native UIs in Rust with Rust code. And a high-level architecture, how does it work? So I'm a user. So this time when I open the app, I'm an instance like this, so we can have many users connected to a single backend. Our backend is written in Go. We have Redis for PubSub, so for real-time communication. So imagine I make a call from one user, it goes to the backend, to the Redis, checks if the other user is connected, and forwards them the call notification. And if they accept, everybody goes and connects to the WebRTC infrastructure to start the call. Yeah, and how does it work? So this is the version 1 of Hop. This one is the main window, this is Tauri, and this is a web view. Basically, this is a browser instance, long story short, that is controlled by a Tauri backend, which is Rust-based. And then we have the core service. Core service is headless, it doesn't need Tauri, so it's responsible for web streaming, camera, audio, screen sharing window, and camera window. So those windows before, in V0, they were all also web views, but we had some performance limitations, which I will elaborate, and then we made them in the version 1 of Hop to be Rust-based. Yeah, really fast because I will run out of time. So for screen capture, initially we used a package called Screen Capture Kit RS, which I was amazed that SVT, this very national television, have open source. I mean, coming from Greece, I would never expect the national television to have a repo in GitHub and have a really cool package. Amazing. Yeah, WebRTC streaming, so remote cursors, replicating the movements and stuff, so everything in core is responsible. And I will now speed run the problems we faced, and we thought that it's not going to be hard when we started. So, when I said before, it needs to be fast. It needs to be less than 100 milliseconds. Okay, how do we measure 100 milliseconds? What does it mean 100 milliseconds? And before I explain this more, the terminology here, setter is the one that shares the screen, controller is the one that sees the screen share window and controls remotely. So the 100 milliseconds goal is not arbitrary. It's defined from Apple. If you want something to feel responsive and not that it's not native on your laptop, it needs to be less than 100 milliseconds. The same is for your browser, the same is everything. Everything that takes more than 100 milliseconds to have a response, it doesn't feel native. So that was the goal. Yeah, and in our case, you can see all the components of a latency. We have frame capturing, that means grabbing the screenshot from the computer, then encode this with whatever encoder you're using, send this through the network to the other participant, decode this, and render this in a window. So those are the components. But if we need to think of the latency, the end-to-end latency, imagine the scenario. I control the remote participant computer, so I press a key, I press space. This one gets through the network to the other participant. Then we remotely execute this space. Then we take the screenshot. We encode the screenshot. We send this back. We decode the frame, and we render the video. So this whole loop should be less than 100 milliseconds, and that's the end-to-end loop or the round trip. And another question was, how do we measure latency? Because WebRTC doesn't come with those internals, it doesn't care about all this round trip with decoding and encoding. So we hacked this out, and what we did is that, as you can see here, it's the original sharing screen. And on the right, there is a thin black strip. So what we did to hack this, we were sending from the controller a tick event. So every time the controller was sending a tick event, the setter was detecting this, capturing a screenshot, then appending a black strip, and sending this back. We decoded, and if we detected that there was a black strip, that means that this closed the loop for the end-to-end. And then we were measuring the end-to-end latency, the round trip. So now that we have a way to measure, and that was before we started the whole project, we needed to understand which codec should we use, because it's a big component on how you use the latency. So there were many available, H.264, H.265, VP6, VP9, AV1. We ended up in version 1 right now with H.264, basically because it doesn't make your MacBook fans go wild, and it has really good hardware acceleration. And we've made some tests, which I will speed run super fast. So by default, if you use WebRTC, And that's why we didn't stream from the browser, because those would be the default settings, and we cannot work with default settings. So if you don't have a good internet, 4 megabps upload, you will be around 340 milliseconds latency and around 150 in good internet, HD and full HD, which is really bad. If you want to be super fast and feel like you are typing on your own MacBook. Then we've made some changes to the WebRTC, mainly how we compress the images. So first of all, we didn't want to compress the images super hard because we want crisp image, so the font will be crystal clear. And how much we allow for the budget rate of the bit rate to fluctuate. And with those two changes, you can see we went below 300 milliseconds for the bad internet and south of 150 for the good internet. Still not reached the goal. The next one was buffer sizes. We changed the buffer sizes, and this one took us to around 170 in bad internet and around 110 for the good internet. So we almost reached the goal. And after painful tests, what we found out is that WebRTC codebase have a specific flag called isScreencast, which does really good optimizations. So in our case, it wasn't set, and it was also limited to 5 frames per second, which is super ugly. I mean, you need 30 plus frames per second to feel native. So we changed this upstream to LiveKit, and with this change, you can see for bad internet, still we are 140, but for the good internet, we reached the milestone of below 100 milliseconds. And as a disclaimer, we have a really nice post around this exploration when we started out. And right now we have way better numbers because for V1, we serve 4K by default. In V0, we were serving full HD. And still we have lower latency after so many iterations. How much time do we have? 2 minutes, okay. So other problems we faced, I will speed run them, is how do you handle different layouts? So I might have QWERTY, my teammates might have QWERTY Z, I might have a Greek layout. So we have a nice implementation around how we tackle them with key code and key maps. Also, how do we handle key binding? So you might press Command and Tab, and you might send a different key code to your teammate. How do you handle this? Another thing that we tackled in the open source is how can I send a character in Greek? So this is the Z in Greek. How can I send this to another person that doesn't have this layout and still be typed? Which was basically just overriding the UTF representation when you send the key code to the OS. Cool stuff, speed running this. OS only allow for one cursor, so you need to do some magic tricks to always have one appearing as the main cursor, even if your one appears like a magic one. So you can see the me, which is the green one. This is actually my cursor, but we changed this with OS magic until you move it again to take action. This is how it works. Speed running this, speed run. Okay, cool. And last thing, why we got rid of Tauri. Tauri is basically WebView instances everywhere, so Chromium in Windows, macOS Safari, Linux Web Support. So this was a browser back in the day. And it led to inconsistencies. So in Windows it was looking really nice, and in Safari, in macOS it was breaking because they didn't support shadows as needed. Audio capturing was super bad in macOS. And if you imagine you have video, screen sharing, and audio is one of the fundamental pieces you need to nail. And you can see how many people hated the audio. So there was a pity to do the really best for latency for screen sharing and then receiving one of the audio, or the audio was a bit compressed. So that was fixed by moving everything to the backend. Yeah, last thing, Linux does not support WebRTC. And with now everything becoming to Rust, we will not have penalties to do cool stuff like upscaling images. So you may share HD, and you can do with almost zero penalty go to HD by upscaling in the metal GPU. Yeah, that's it. I just pre-run this. We just moved to Rust, cool stuff. Open source repo. Give us a star if you want to test this. If you want to give us feedback, please go ahead. If you want to self-host this and your company is, privacy aware, you can self-host this. Yeah, that's it. Thank you.
Questions?
Do you have is there any feedback or like debug mode where you can see if you have latency, for example, or a problem that the user could see on what users and the problem is, or what layer?
In what layer? That would be amazing. Not yet, but kind of. We have. So I think I can only see if I'm in the call. Let's just double check this. Yeah, we have a thing called OpenStats. I just clicked on it. Should be okay. Let me. So we have this, which you may know this as a nerd stats in some cases. So it's just a stats window, super ugly, okay? But we want to expand this and provide more information here, and also cluster this per participant, because you might not be the one that has a problem with the latency.
Hi, a few things. Do you prefer to meet people and sit down and pair program still, or do you prefer your own environment?
If I prefer to meet, you mean in person?
Yes.
Technically, yes, though the last 3 years, maybe more, I work fully remote. In Grafana, for example, there is no concept even of an office. So there's not even that possibility to meet in person.
So back in the day, 25 years ago, when we started to promote programming, we had these discussions with pointy-hat bosses that didn't want to. They fragmented teams. It's not the same as remote. It was just that they didn't want to structure the architecture so that it was unnecessary fragmentation, that people were on different sites and were not allowed to pair programming.
They were not even allowed to pair program.
Because we didn't have the tools. We didn't have tools like yours. So then it became solo programming in the same project across time zones and so on, instead of structuring work so that you could do it in the same time zone, maybe work together and so on. I just checking your position on that, because that was a discussion we had again and again.
And I think this literally shows the culture of the company. For example, in Grafana, they don't only embrace it. Onboardings happen with pair programming, so you spend a lot of time, so you're encouraged to do a lot of pair programming. And at the same time, you're encouraged to do cross-department work. So your manager will just tell you, you have this goal, find the department you need, poke the people, and work inter-team-wise.
Two more things. One thing is that WebRTC was heavily contributed to in Gothenburg by Ericsson.
Okay.
I met some of core developers 10 years ago, and we collaborated on getting WebRTC working with Pi cameras on Raspberry Pi, doing a strange session. And they told me that Ericsson had been funding them for years, and not anymore, but it was Ericsson that did, or it might be fun for the locals to know. And the final thing is, what about in the age of AI, when people actually pair program with AI? And the concern is that an experienced engineer can get good results from agentic development these days, and not necessarily splitting on 30 agents, but still. We now talk about working on three. So one is junior, one is senior, and one might be even AI, so that we still can grow people on experience, working together, also being a driver, not just sitting next to someone.
Actually, you know, also there notice, yeah, I'm fully bullish in the era of AI around pair programming.
Yeah.
For example, I'll give you a concrete example. I was pairing with a junior, and they were using agents, and they used an agent, for example, to formatization, which is money spent for the company, for the AI models just to formatization, which is mental. So this is a really great opportunity from my perspective, especially to the junior to senior dynamic, to train your juniors to become seniors. Because, you know, back in the days you would need it until at least juniors to review your PRs, to do the boring stuff, the tests, etc. But now you, as a senior, you have the agents, and you maybe don't need them anymore. So this is a great opportunity to just train them, from my perspective. But at the same time, still, there is one survey from Atlassian, how much time we spent coding. And they found out, for example, that we spent 17% of our time coding. So the rest of the time is stuff that doesn't even involve coding. It might be review, it might be collab, it might be design docs, debugging. Yeah.
If you pair program all the time, you get drained. And what we love, we used to have the rule of thumb that only 1/3 of your time times 2. So people in smaller companies was concerned that they only would get 15% of productive time. But
this talk, the VP of Engineering of Shopify actually addresses this really, really nicely.
I should say that when I went to a large global organization within Ericsson, one third of Ericsson back then, they said, we have actually measured and we would hope to reach 50%. That would be great. And that was not people being lazy, just a human nature of what you can, how much you actually can produce and what you need to do to sustain yourself and sustain
yourself is also, you know, accountability, right? I mean, I scheduled something with a teammate, there's accountability there that we need to deliver. So you don't want to be embarrassed in your teammate, your colleague, that you don't deliver when you program to do something together.
Well, yeah, it's not a story.
Yeah.
But you can questions there.